Hello everyone. The content of this lecture is Basic Principles of Value Engineering 1. This course will cover the following three aspects: the emergence and development of value engineering, characteristics of value engineering, basic concepts of value engineering. 1. The emergence and development of value engineering. In 1947, value engineering originated in the United States, which initiated by L. D. Miles, an engineer in the procurement department of General Electric Company. It started with material substitution and gradually extended to improving product design, processes, production, and other fields. Example: replacing asbestos boards with fireproof paper. What is value engineering? It is not a physical engineering discipline, but rather a management philosophy or idea. Let's first look at the concept of value engineering. We can understand it as a combination of ideas and techniques. When talking about value engineering, we must mention its founder, L. D. Miles. A typical example is the asbestos board incident. At that time, the price of asbestos boards needed for General Electric's production increased exponentially, posing significant challenges for procurement and budgeting. Miles started thinking, why do we need to use asbestos boards? What function do they serve? It turned out that workers were laying something on the floor to prevent it from getting dirty when applying paint to products. Since the paint solvent was flammable, the fire department required the use of asbestos boards for fire prevention. Due to the scarcity and soaring prices of asbestos boards, Miles decided to find alternative materials. We needed the fireproof function of the asbestos boards. Starting from functional analysis, Miles identified various materials that could provide fire protection. The next question was, among these fireproof materials, which one has the lowest cost? The answer was fireproof paper. Using this analysis method, Miles purchased a large quantity of fireproof paper at a relatively low price, effectively resolving the procurement crisis. In subsequent procurement, Miles followed the same approach. First, analyze the required function, and then choose the method with the lowest cost that meets the functional requirements. Finding this method highly effective, Miles gradually developed it into a systematic management philosophy and technique, which was later promoted across various industries. This is the origin of value engineering. In 1955, Japan introduced value engineering from the United States. Following this introduction, Japan's economy experienced significant growth. During the period of Showa economic miracle starting in 1955, the gross national product grew by 12% annually, and consumer spending heated up. From 1957 onwards, the three major appliances for consumer goods, washing machines, refrigerators, and black and white televisions, rapidly became common in households. China began introducing and promoting value engineering in 1978. In October 1987, it issued the national standard of the People's Republic of China GBA 22387, Basic Terms and General Working Procedures for Value Engineering. From 1979 to 1989, Shanghai implemented VE activities in 373 companies and enterprises across 4 industries: light industry, electromechanical, textiles, and instrumentation. Over 580 improvement projects were carried out, resulting in cost savings of 250 million yuan. From 1978 to 1989, FAW completed 270 VE projects, yielding benefits of over 30 million yuan. Datun Coal and Power Company promoted VE in its material supply system, generating over 54 million yuan in benefits in 8 years. After 40 years of practical application, the theory and methods of value engineering have been widely recognized by both academia and the business community. It has become one of the effective methods for improving product quality, reducing costs, and enhancing economic benefits. Value engineering VE, also known as value analysis VA, focuses on the functional analysis of products or operations, aiming to enhance their value. It strives to achieve the necessary functions required for product or operation use with the lowest life cycle cost through organized creative activities. Therefore, value engineering is not solely about blindly reducing costs or increasing functionality. Rather, it considers both function and cost holistically. So, at which stage of product production is value engineering applicable? Actually, value engineering can be applied at all stages of product production to increase the value coefficient. However, the degree of improvement varies when applying it at different stages. 2. Characteristics of value engineering. First, objective of enhancing product value. Value engineering aims to reliably achieve the functions required by users at the lowest life cycle cost to obtain optimal comprehensive benefits. It is a creative activity dedicated to providing value. Core focus on functional analysis. It systematically examines the relationship between functions and costs. Emphasis on continuous reform and innovation. Value engineering focuses on work during the research and design phases of products, seeking technological breakthroughs. It is a planned, organized, and led management activity. 3 basic concepts of value engineering. Value engineering is an organized activity that strives to reliably achieve the necessary functions of the research object at the lowest life cycle cost, with a focus on functional analysis. Value equals function cost. Value is closely related to function and cost. Let's first look at the definition of function. One function refers to the performance, use, and utility of a product or service, i.e., its use value. For instance, the basic function of a load-bearing wall is to support weight, while its auxiliary functions include insulation, heat resistance, soundproofing, and space division. Take wallpaper as another example. Its usage function is to protect our walls from contamination. Does it have an aesthetic function? Wallpaper comes in various patterns, which serve an aesthetic purpose. So, what is a necessary function? It refers to a function that is essential, based on their nature, basic functions, auxiliary functions, usage functions, and aesthetic functions are all considered necessary. That means we not only need load-bearing walls to support loads, but also require their auxiliary functions, such as insulation, heat resistance, soundproofing, space division, and protection from wind and rain. Similarly, for wallpaper, not only is its usage function necessary, but beauty is also a must. for everyone. Therefore, the aesthetic function is also essential. So, what is an unnecessary function? It refers to functions that are redundant, repeated, or excessive. Redundancy and excess are classified based on quantitative standards of functions. Excessive functions mean that there are more functions than needed. We don't require that many functions. Insufficiency, on the other hand, means the opposite, not enough functions. For example, if an ordinary person wants to raise pigs at home, could they use a fence made of tree branches? Think about it, class, could they? No. Because the strength of a fence made of tree branches is insufficient. This is an example of an insufficient function. So, could we use concrete to build a wall? The lowest grade concrete, such as C10 or C15, would suffice. Using C100 concrete to build a pigsty would be excessive. I hope you understand what excess and insufficiency mean. Excessive functions should be eliminated, because although using high-grade concrete for a pigsty may meet your requirements, it would result in higher costs. Generally, people use bricks to build a wall because it meets the strength requirements and is cost-effective. So, please keep in mind the concepts of excess and insufficiency regarding redundant and repeated functions. Consider a refrigerator with a recording function that has been heavily promoted. The main functions of a refrigerator are to refrigerate and freeze food. Recording is a redundant function for a refrigerator. This redundant function will increase costs and result in a higher price. Therefore, redundant functions should be eliminated. 2. Life cycle cost. In value engineering, cost refers to the total cost that users are willing to pay to obtain a product's functionality, encompassing all expenses incurred throughout the entire life cycle. Life cycle cost C equals production cost C1 plus usage cost C2. Research and development costs plus design and manufacturing costs. Life cycle cost refers to the cost incurred by a product throughout its entire process. Production cost includes not only the cost of production and manufacturing, but also the upfront research and design expenses. In short, production cost is the price that consumers pay to purchase the product. That means, besides the cost of buying a product, there's also a cost to using it. Therefore, when considering purchasing a product, consumers will also take into account the usage cost. 3. Value. It aligns with the commonly used standard of good quality and low price. When consumers purchase a product, they often say it's worth it or not worth it, which reflects the concept of value. The magnitude of value is represented by the ratio of function to cost. That's all for this video. Thank you, everyone.